Hello, this is Yo-Yo. So today we're going to talk about fitting linear models to data. So in the real world, um, rarely do things follow trends perfectly, right? When we expected the chain to behave linearly, or when inspection suggested the chain should behave linearly, it is often desirable to find an equation to approximate the data. Like finding the equation to approximately the data helps us to understand the behavior of the data and allow us to use the linear model to make prediction about the data inside and outside of the data range. So let me show you an example. The table below shows the number of cricket chirps in 15 seconds and the air temperature in degrees Fahrenheit. Plot the data and determine whether the data appears to be linearly related. So here's the, if the temperature is, so how to interpret this table. So if the temperature is 18.5 Fahrenheit, the cricket chirps 14 times, 14 seconds, And then if the temperature changes, the frequency of chirps will change as well. So how do we plot it? You can draw a data and plot it, or I'm going to introduce you a website which is really useful in terms of predicting the data. So when you open Google, you type in Geogebra and we'll give you Geogebra Classic. Make sure that you choose the classic one. And then on the upper right, you will see there's a sandwich, and then below the sandwich, which is 3 lines, and there's a sandwich and the triangle circle, and next to it you will see 3 dots. You press 3 dots and add a spreadsheet. Okay, so let's type in the data that we have. The chirps. So here is the chirps. Oops, I typed in that wrong. Let me pause the video and type in this. Okay, I just finished typing all the data in, which is the chirps and the temperature. This is the first line usually represent the x-axis, the second not line. This first column represents the x-axis, and then the second column represent the y-axis. So when you highlight the data that you input on your left, you will see a bar. You click on the bar, they have 1 variable analysis and 2 variable analysis. So pick 2 variable analysis, and then they will get you the scatter point. So when you look at this scatter point, what do you think? What's your first thought when you see this scatter point? These look like a linear function, why it almost can fall into a straight line. But now try to draw a straight line by yourself in here. So maybe the line that you draw is different than the line that other people draw. So what will be the best line to draw to fit in all of these points? So in here, luckily, GeoGebra will help you to find the best fitting line. Once you choose the regression model on your lower left, see the regression model that have none, you can choose linear, logarithm, polynomial, power, exponential, growth, science, and logistic logarithm. So now let's choose linear because this looks like a straight line for us. So here, GeoGebra will analyze this for you. So they give you the model. Y is equal to 1.1432 x plus 13.2806. So that means the slope equals to 1.1432, and the x, the b, which is our y-intercept, equals to 13.2806. Okay, but this is not the nicest things. on your right corner, did you see this is the Greek number epsilon x? This shows you the statistic related to the data that we have. If you press this, they will tell you that, hey, the mean of x is 31.1, so the average chart that they recorded is 31, and the mean, which is the average temperature, is 65.83. Okay, but the most important thing for this class is the R value. So in here, R value is 0.95.9. So what does this mean? Well, I'm going to introduce the R value to you. Let me show you the screen. So the R value is called correlation coefficient. Is a measure of how closely the line fits the data. So the R has to be in between 1 to -1. So if R is a positive number, that suggests that what? From what we know about positive number, that means this is a positive relations. That means this is going to be increasing. The line is going to go up. And then if R is less than 0, that means suggests that x and y has a negative relationship. And this is going to be a decreasing line. And then this is the most important thing. If the closer the value is to 0, the more scattered the data is going to be. So that means, okay, if the data look like this, so R is going to be, the absolute value of R, I should say that, is going to be close to 0. But if the data look like, let me use different color of pen. Oops. Doesn't work. If the data look like this one, wow, it's really close to straight line. That means R is going to be close to 0, absolute value of R, because they could be a negative, which is if the function look like this one. Look, it still very look like a 9. So R is going to be close to -1, right? So I'm going to say this again. The closer the value is to 0, the more scattered the data is. The closer the value is to 1 or -1, the less scattered the data is. So this is R value. So when it comes to the strength, how correlated to the data to the line, if they're really close to 1, we will say, hey, this is strongly related to, the data is strongly related to the linear function that analyzed by GeoGebra or by any other technology that we use. You can either use some calculator, some scientific calculator have that function that you can analyze the data. Or if something like that, we will say, hey, this is really weakly related to the equation if the data is really scattered. Here I'm going to introduce another concept. It's called interpolation and extrapolation. So what is interpolation? Interpolation is when we predict a value inside the domain and the range of the data. Extrapolation is when we predict a value outside of the domain and the data. So for example, in our earliest example, the temperature as a function of chirp in our hand, the model that we did earlier. So the interpretation would occur if we use our model to predict the temperature for the chirps between what? Let me show you the graph again. Let me show you the table again. So in here, what is the domain? The domain is from what? 18.5 to the highest data that we connect is 14.4. That means if we're trying to predict something in between this range is called interpolation, such as, okay, our data, we have what? We have 14.4, 13.5, 20.5, 13.3, 13.1, 13.5, yada yada, but we don't have 13a. That means we can use our linear function, whatever that we earlier we got from Geogebra, which is y equals to 1.1432x plus 13.2806. If we use this linear function to predict, okay, if the cricket chirps in 38 seconds, what is the temperature is going to be? That is going to call interpolation. So what is explanation? Explanation if, okay, we're trying to predict something that outside of the range, which is, okay, so somehow we want to know the temperature if the cricket chirps, maybe chirps 10 times, chirps in 10 seconds. So what would be the temperature? So this is outside of the domain, right? So this we call explanation. Okay, so after we know all of these, let's do an exercise. So here's the exercise that I found. So gasoline consumption in the US has been increasingly steady. Consumption data from 1994 to 2004 is shown below. Determine if the trend is linear, and if so, find the model for the data. Use the model to predict the consumption in 2008. So in 2008, this is going to be what? Outside of the range, because the range is from the year 1904 to the year 2004. And then outside of 4 is going to be what? Outside of 2008 is going to be outside of the range. So this is going to be explanation. So now let's use GeoGebra and let's do this together. You can also pause the video and try to do it by yourself. Okay, so the first step after we open GeoGebra, we want to put the data in, right? So now A is become the year. And then the next one would be the consumptions, billions of gallons. Okay, I'm gonna pause the video and type in all of the data. Okay, I just finished typing the data. I don't know, did you type in the same thing as I do, or you found there's some problem? Okay, if you take a look, you may notice that the year, instead of I type in 1904, 1905, 1906, 97, I use 0, 1, 2, 3, 4, 5, 6 to 10 to represent the year that they recorded. Why I do that? Because if you use 1904 and 04, the data when they put in on the X9, they're going to do, okay, 1904, 1905, 1906, go all the way from 1904 to the right. And then after you hit 99, they will go back to the origin, to the left, to do 0, 01, 02. So the data is not going to be the same. So the best way to do that is, instead of the year, the exactly year, we do the year since 1994. Okay, so now let's see if you still remember how to do it. You highlighted all the data that you have, and what would you do? You click on the upper right, the second icon, not upper right, I'm sorry, upper left to the second icon, and then choose two variable regression analysis, and then they will show you a graph. And this time they even give you a line. If you don't have a line, because you haven't choose the model yet, you can, there's a drop down menu for you to choose the model. None, logarithm. See logarithm? Because this doesn't look like a logarithm for the computer to analyze. That's why they don't have the result. Or polynomial. Yes, if you look at polynomial, maybe this is not the best fit data for it. So again, now we are working on linear, so you have to choose linear. So now take a look. They give you the function, which is y equals to 2.2091x plus 113. And then on the upper right, choose the first icon, which is show statistic, and you will find R value equals to 0.0095. So how do we predict? But we're not done yet. They want you to predict the year in 2000, the consumption in 2008. So that means we want y equals to what? Well, remember, when we're connecting the data, it's since 1994. So in year 2008, so this should equal to 14, right? So in here, we can type in when x equals to 14, that will give you the calculation. Oops, what did I do? And then they will give you y equals to 114.4. See, you got the answer. This is the consumption that we predict using our model. This is really interesting, so I suggest you to play around the data. Okay, let me know if you have other questions about GeoGebra or this topic.